Hello, welcome back to College Algebra. Today we're going to talk about the logarithmic function, but is the inverse of what we learned the last time about the inverse of the exponential function. So let's just start by giving an example. If we say that 2 to the x equals 16, can you find x for me? We know before that if I ask you that x squared equals 16, you take the square root of both sides and get x equal plus or minus 4. Now, I'm asking you about how to get this exponential function, how to get x, the value of x when, when x is in the exponent. So the answer to that question is, I ask myself 2 to what equals 16? Simply 2 times 2 times 2 times 2, so 2 to the 4th power equals 16. Therefore x equals 4. So this is the idea of the logarithm function. So the logarithm function is to evaluate that x, the exponent, okay, given the base and what we call this the argument or the answer in this example. Okay, let's define the logarithm function and we see how we solve some examples based on what we have here. So first of all, we let x and b be positive real numbers. And b is not 1, as we learned about that in the exponential function. Okay, then the function y equals log b to the x is a logarithmic function. Log bx is a logarithmic function. We call b the base, and we call x is the argument. Okay? So here, b is the base, and m is the exponent here. So b to the m equals x. This is the exponential function. So this expression is the exponential function that we learned about the last section. Now we can convert this. So here's the base, I say log, and the base comes down. So the base is here, and then the answer of the exponential function becomes the argument of the log function, and the exponent becomes the answer here. So this is the base, this is the argument, and that is the exponent. Okay? Again, to convert from exponential to logarithm function, we write log, and the base, we take the base down there, and the answer of the exponential function becomes the argument of the log function, and then the exponent becomes the answer here. Okay? Let's get some examples about that to develop this idea. Okay, I have an example here is to convert these expressions from, we convert to a logarithm, to log function, or let's say expression. So the first one, I have 7 squared equals 49. Example 1. So here I am going to define the base. Write log first. Log. And what is the base here? Basically 7 is the base, so 7, okay? And I'm going to write equal here. What is the exponent? 2, so the exponents go to the other side, and the answer becomes the argument here. So log base 7 of 49 is 2. Why? Because 7 squared is 49. 7 squared, base 7, exponent 2 equals 49. Another example. 4 to p equals q. 4 to p equals q. Okay, what is the base? The base is 4. So write log first. Log, and I have the base 4. And what is the exponent? The exponent is p, and argument is q. So log base 4 of q is p. Okay, one more example. Let's write that down here. Example 3, log log 9 to 3 equals 1/2. So now I'm doing the opposite. So now I converted from exponential to log. Now I'm gonna do from log, convert from log to exponential. Okay, think about that. Where's the base here? The base is 9. And where is the power? Or the exponent is 1/2. And argument becomes the answer. Okay? So let's get another example. Convert log also to exponential. So I have log, this is number 3, this is example 4. Log log c to 8 equals 2r. Again, what is the base? The base is c, and exponent is 2r, not 2, not r, but 2r together, equals the argument, which is going to be the answer here, is 8. Okay, I hope that this is clear. So we talked 4 examples here on how to convert from exponential expression to logarithm expression, and the opposite from logarithmic to exponential. I hope that this is clear so far, and now we're going to move to explain some properties. We're going to take them by examples first, and then we're going to state the properties. Okay, so now we're going to evaluate some examples. So I have log 2 16 is what? Do you remember I gave you this motivation example? So you think about that. I'm looking for the exponent 2 to what power, what exponent gives me 16. So I write it this way, 2 to what equals 16. So basically 2 to 4 equals 16. So the answer, log 2 16 is 4. One more. Log 12 of 12 equals what? So again, ask yourself, 12, the base, 12, not this one, that one, 12, to what power equals 12? So the answer is clear, that 12 to the first power, to 1, equals 12. So here is the answer, is 1. One more example. Log 5 of 1 is what? So again, 5, take the base, 5 to what equals 1. And this is a common exponential property, or exponents properties, is anything, any positive number, a to 0 is 1. So 5 to what is 1? 0. So the answer here is 0. Is it clear? Okay, let's get one more examples, probably two more. Log base 1/2 of 4 equals what? I'm going to stop here for a second. I want to explain here. I'm looking for the exponent. So 1/2 to what power equals 4? Well, I know that 2 squared is 4. But now I'm not having 2, so I'm going to write 2 first. But I don't have 2, I have the reciprocal of 2. When I'm thinking about the reciprocal, I'm thinking about the negative exponent. So therefore, I'm going to put negative 2 here. So the answer would be negative 2. Okay, let's get one more example. Log 5 of 1/25 equal what? So now again, what is the base? The base is 5. To what power equals 1/25? So it's similar to that example, but they have the reciprocal here. So 5, I know that 5 to the second power, 5 squared is 25. So 5 squared gives me 25. But I want to get the reciprocal of 25. So what does that give me? So that means that I have to put the negative, as we used in the previous example. So I have 2, and I have negative 2 here. So negative 2. So again, the same answer, negative 2. I hope that this is clear so far. Now I'm going to talk about defining two common logarithms. The first one when we don't write the base, so I write log, let's say just log, common log. When I write log here, that means, or let's say log x, that means the base here, when I don't write the base, that means the base here is 10. So it's the base 10. So when I don't write the base, it means that the base of the log is 10. Another one, we call it the natural log. So the natural log, I write it as natural log ln of x. And when I don't write the base here, that means that it has base, the natural number before that we had the last time, which is e. So basically here there is hidden 10 and there is hidden e. Okay, I hope that this is clear. So I call this the common log and this is the natural log. And of course I don't write that. Okay, so let's take some examples about that. When I say evaluate log 100, so based on what we did before, what's the base here? The base here, it's log, it's hidden base here, so that means that the base is 10. So to answer that question, I say 10 to what power is 100? And basically 10 squared is 100, so the answer is 2. Okay, another example, the natural log of e to the 5th is how much? So what is the base here? The base, if the natural log is e. So in other words, I'm saying e to what power equals e to 5th. And obviously this is clear. E to 5th equals e to 5th. So the answer is 5. So the answer is always the 1 in a square. Okay, so let's get some stuff. I would like you to understand how to use the calculator in these examples. So if I ask you to do log 31589, all you need is just to type log in your calculator and that number, and you should get 4.4995. By the way, in your exam and in your homework, okay, I don't ask you for many decimals, but you must provide 4 decimals. Okay? So always 4 in logs. Okay, another example. The natural log of 1.214. So you type ln, or natural log 1.214 in your calculator, and you must get 0.1939. One last example, log 5 base 5 to 12.8. Now I can't type in the calculator just log, okay? There is 2 ways to compute that. I'm going to tell you one way right now. In some calculators you can have log base, I think it's called log base, and x goes first, and then the base, I think. So for this one, you write log base, or you type log base, and then we type here x first, so 12.8, and then 5. So there's some options. Eventually we're going to learn about how to split that, and we get it log 12.8 over log 5, and then that gives me the same answer. And if you compute this way or that way, both, we're going to get 1.5841. We're going to learn about the change of base properties eventually in this and the next section. Okay, I hope that this is clear, and if you have questions, don't hesitate to ask me. Alright, so based on what we learned from these examples, we have to derive the properties of the logarithm. So I'm going to talk today about 4 properties before I stop that video and go to the other one. Alright, so the first property log b to 1 equal 0. So again, this is property comes from b to what power equals 1. So b to what power, and I have talked about that before, that b to 0 must be 1. That's why the answer is 0. b to 0 is 1. The second property is log b to b equals what? So b to what power equals b. So basically here, that must be 1. So the answer is 1. The third property and the fourth one, I will write it down here and I explain how we did this. Log b to the x equals x. And I have to explain something here. How did I get this one? So we learned before the exponential function f of x equals b to the x. Okay? And the log function, or the inverse, which is the inverse of the function, f inverse of x equals the log, which is log b to the x. So this is the log function, and this is the exponential function. But the log function is the inverse of the exponential function, and the exponential function is the inverse of the log function. So based on this rule, I'm going to derive the third and fourth rule. Okay? So basically, I know that when I have 2 inverse, that f composed to f inverse of x must be x. Correct? So let's write this down. So here's f of f inverse of x is what? I think I switch it. So I'm gonna call this first, but we're gonna use this rule anyway. So f inverse, component f that is f inverse of f, which is equal what? So I start with the outer one first. F inverse is this one, and log b, and you remember I told you, open the parentheses and plug f of x. And what is f of x? B of x. And those are the inverse of each other, so that must equal to x. Therefore, that's why log base b to b to the x is x. The other one is b to log b to x equals x. So this is the one that I was talking about, the other one. So I'm going to switch them this time. So I'm going to say that f compound f inverse of x equal, I start with f outer function of f of inverse of x. So again, this is the same idea here, but I start with f, which is b to the x first. So this is b, and I keep x empty here, and I plug the f inverse, which is log b to the x. So I have log b to the x. And again, f and f inverse are the inverse of each other, so I must get x. That's why b to log b to the x equals x. So these are the 4 rules that we have to learn about them so far. Log b to 1 is 0, because b to 0 is 1. Log b to b is 1, because b to 1 is b. And number 3 and 4, log b to the x is x, because these are the 2 inverse function, as I explained here, and equals x. And the other one is the opposite of this one. So I have b to log b to the x equal x. Alright, I hope that this is clear. And in the next part of this section, I'm going to talk about graphing the logarithmic function. Thank you, and see you in the next video.